Hello and welcome to the Dustin and Eric podcast show brought to you by Mimosa Networks. Hi, I'm Dustin.
And I'm Eric.
Today we're on episode number 22. We're talking about gender. Gender A and B in the Mimosa radios, people, not, other stuff. Even though it's Pride Month, so we're talking about TDMA protocols. So special guest is Jeff Jones from Mimosa Support.
Hey guys, good to see you again.
I guess he's not really a special guest anymore. He's kind of like a permanent resident of the show.
I am.
I guess that means you have to be here every episode from now on.
As long as you keep paying me, I'll be here.
Okay, not a problem.
Hey, Jeff, can you hand me my coffee and make it double? No, I'm kidding.
Here you go.
All right, so today's main course is, should I be using gender A or B? So on the AP link page in your backhaul radio or your access point radio, you can change gender between A and B if you're not in auto mode. Auto mode only applies to backhaul radios. So here's an example of switching between 248 milliseconds and then gender A 5050, A 7525, B 5050, B 2575. So a lot of people will go, what does that mean? So today we're going to talk about gender A or gender B and what that means.
So the importance of GPS and clock accuracy. A highly accurate and precise clock is needed for time-based protocols like TDMA to work reliably, especially across back-to-back links. This is because radios at the same site must synchronize their communication to avoid interfering with one another.
Yeah, so if your radios are in competition with each other in their gender roles, what will happen is one radio will be transmitting while the other one is receiving, and that other radio will actually show up as interference on the actual spectrum because it will no longer mask that transmission because it will be receiving on the other side.
So for those of you watching from home, this is an example of somebody who hasn't got the same gender at the same location. So you can see that they're transmitting and receiving at the same time, so it's causing interference.
Right.
So if we go back here, and we have an example of AB-BA configuration for genders. So you've got both A's transmitting at the same time and both B's transmitting at the same time.
Yeah, I always likened it to, I'm a terrible dancer, but they say if you do the waltz and you stay in time with the music, that even a bad dancer looks halfway decent. So when your genders match correctly, even in a rough or high noise RF environment, the proper gender selection will mitigate interference just because of how that opens and closes the transmit and receive window accordingly.
Is it a good idea still for some channel separation? Even though I'm using, say, B and B on the co-located backhauls, and the A radios are coming in. What if this A radio sees this other guy on the back, say nearby on the backside of the other 5 gig radio? We still want some separation in there when possible.
Yeah, even if you're not on the same channel, that's a good point, Eric. If you're not on the same channel, it's kind of a rule of thumb to entertain the idea of having the same gender on the same tower, just for that very reason. If you have, say, 5 or 6 different access points on the same tower, and say each of them are on a different channel, by having the same gender selection on all those said radios, it would again mitigate any type of co-location interference or even co-location frequency interference.
So what's keeping in TDMA, et cetera, what's keeping the radios accurate, the time in the clock circuits in these radios?
Yeah, actually that's done through the GPS sync. Each of our B series radios and our A5, A514, A5C radios have a built-in GPS receiver, which uses the atomic clock that's built into each of the satellites there as a timing mechanism to ensure that the millisecond window is adhered upon for all the radios that are being controlled by that GPS sync.
Right. So it's called a fixed super frame, or at least it is for our technology.
Yep.
And it can be modified in several ways. So again, that's the traffic split we talked about earlier, and then the TDMA gender, which is what we're talking about right now. And for those of you who can see this and aren't just listening to it, I do have a slide here on the screen that kind of breaks it down a little bit for you.
So what's it? So I have two links. I'm co-located. I got two B5s on the tower, and I've got one traffic shaped at say 75-25, and the other guy's 50-50. Not an issue.
It is an issue. They both have
Okay.
to be the same traffic split and gender,
Okay.
and the same time TDMA window as well.
Okay. Yep.
Also, it goes back to our last episode, episode 21, where you need to have a decent angular separation between the radios as well. So you can have 4 B5s on the same tower without overlap. You can have 8 B24s on the same tower without overlap.
Yeah.
So if you're overlapping your antenna patterns, you will have interference if you're using the same channel. I actually had a chat earlier today where somebody had 2 B24s sitting right next to each other, shooting to the same point on the other building, wanting to use frequency reuse, and that's impossible.
I guess another thing that you can do is look at the bandwidth too. You know, you're running a single 80, maybe you can drop that down or into say a 2x40 or a single 40, or depending, and then separate the two channel, the 240 meg widths here up and down part of the spectrum, if you've got that available in your spectrum, right?
Yeah, but I think one of the first things that I see a lot of customers have confusion about is how RF operates and how it's received and transmitted from an actual radio. When it transmits from the radio, it's a very, very tight pattern. But as it's being received on the other end, it's no longer a tight pattern. So we like to encourage our customers to have at least 10 feet of physical, lateral, and vertical separation from the other radio, because when that signal is coming in from the horizon, if you will, and you say you have a couple radios that are coming in from that horizon, those signals are not tight like it is when it comes off propagates off the radio. So, having some separation, like Dustin said, really helps a lot. And I think it's one of the first common mistakes I see customers having, where they put the radios right next to each other and wonder why they're having high SP errors or a lot of noise floor issues. So
and in the same line, look at multiple towers. Maybe you don't have a single tower; you've got two or three, or a couple of masts,
right?
And they're separated by X meters or so. So you could have incoming traffic is still interfering on tower B over here, right?
Right.
So there's a lot of stuff in play.
Yeah, that's where GPS is an excellent way to mitigate again frequencies, but it's not the only thing that you need to be concerned with. Like Dustin had mentioned in our previous episode, having physical separation of the radios from each other will always help you in the performance.
Right. So Jeff, in your professional opinion, how close do the towers or locations need to be using the same gender or a different gender, so they're not interfering with each other? Because I know a lot of people do, say, micropops, and they've got, micropops every, 600 meters or something like that. Yeah,
I think in a point-to-multipoint scenario, I'll give you the official answer. It's the engineering answer. It depends. The thing that you need to be concerned with is if that other radio can literally see the other radio in its spectrum. So one easy way to do that is to do a physical site survey. You can use the survey built into the radio and see what kind of a signal strength you're seeing. Mm-hmm. If the signal strength is, say, 80 dBm or negative 80 dBm or less, then you may be able to get away with a different gender. But if it's negative 80 or say 70 or higher, then you may want to consider using the same gender so that you're not interfering.
Right. So if you're looking at your scan for ID, or you're just looking at the 5 gig field out there, so looking you'll see your access points out there coming in.
Right.
And you'll see other folks 5 gig coming in.
That's right.
And then you'll look at the negative levels. I think we get some AGC or some thresholds, and we know we can't connect it, whatever, some magic number, with neg 81 on this radio or something, or 83. So no matter what, and you tried to do your best, rescan, kind of line things up and rescan, it's still at neg 81, and everything's lined up. Not gonna link up. You've got something obstruction. You've got some interference. You've got something going on. Right.
And I think the one thing that I would also encourage folks is to understand that The GPS sync only applies to Mimosa radios.
Stop stealing my thoughts, man.
Hey, I'm reading into your mind
That's
there.
fine. Go for it.
He's looking at his Jedi.
Well, I'll let you
cup
speak
right
more
here.
to it, but one of the things that I've seen is folks using other competing technologies and that have a GPS element built into their radios. That's all well and good, but unfortunately, our TDMA technology / GPS sync is exclusive to Mimosa, just like any other competitor that's out there. They're using their own secret sauce, if you will, to communicate between the radios as well as the timing sequence. So with that being said, I'll let you go ahead and elaborate on that.
Sure. The only thing that I'll add to what you said is that there's another common misconception that GPS doesn't help mitigate interference from other sources, like routers or other vendors, regardless if that vendor has GPS sync or not. GPS sync is meant to, again, sync Mimosa equipment
It's
to each other.
internal timing to the link.
Right. So just because you have GPS sync doesn't mean you're not going to see less interference from
good
other
point.
outside sources.
Sure. Yep.
Yeah, I like the word mitigation because it doesn't eliminate it, but what it does is it compromises the RF environment. With GPS sync, it literally opens and closes the transmit and the receiving door, if you will. So if there is any type of external interference, it can shut out that interference while it's transmitting or receiving.
All right. So my last question here is it gender A or gender B? Which one do we choose?
We choose both.
No.
for the
Which one are you going to
application.
choose? You have to choose one or the other.
Oh.
A or B?
Well, you know what my answer is going to be. It depends, right?
That's it.
It depends.
All right, guys. Well, thanks for being on the show. We really appreciate your
Closing
help.
thoughts?
And no
Closing
closing
thoughts,
thoughts.
yeah. Okay.
Do you have closing thoughts?
No, just to close.
I do have some closing thoughts. One thing I would say is if you are planning your network, don't wait until you start hanging the radios to actually decide which gender A or B you're going to use. A really good way of designing your network is to literally draw it out in a topological type of network design, and then you can literally, if you're doing like a series of radios, you can figure out, okay, which radio will be gender A, gender B, and then plan that early on paper so that when it comes time hanging the radios and configuring them, you're not trying to figure it out, but it's already been decided.
Right. Perfect. I actually draw all my stuff out anyway by
Me
hand
too.
because it's a lot easier for me to do.
Yep.
All right, guys. Well, that's it for episode 22. We'll see you on the next episode where we'll be doing another episode of Help Me Help You.
See you guys.
Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.